Session 8.4, comparing proportions from two populations. From the session 8.3, we performed the hypothesis testing about the population proportions. And then we only have one population at the session 8.3. For these sessions, we also conduct a hypothesis testing, but this time we're gonna comparing two population proportion. Let's look at this example. In January 2014, January 2014, the organization reported that 45% of Americans report feeling pretty good about the amount of money they had to spend. So the sample proportion, that would be equal to 0.45. And then in January 2015, report that 49% of Americans felt this way. So this time the sample proportions become 0.49. Both samples had a sample size of 3,500. So N is going to be 3,500. Same idea for this one. Can we conclude that economic confidence has improved since 2014? Or could this difference be due to trend variation during the sampling procedure? So you could see we do have two populations here. And then we want to compare the difference in between these two populations. So this kind of the questions, first I need you guys to let the proportion. We're gonna let P1 be the population proportion of Americans report feeling pretty good about the amount of the money they had to spend in 2014. Okay, that would be your P1. So, and these populations, I'm gonna call this as a sample proportion P1. This is gonna be your N1 in here. Okay, and then we're gonna let P2, same thing here. And that will be in the 2015. So I'm gonna put sample P2 here and 2 here. Okay, make sure you guys remember when you deal with two populations, you have to state which one is going to be your P1, which one is going to be your P2. Okay, so this is what I say. Let P1 be the proportion of Americans who felt pretty good about the amount of the money they had to spend in 2014. And then the same thing with the P2 in 2015. Okay, first things you need to do. So if we want to comparing two population proportion, the null hypothesis, just like the session 8.2, the first thing you need to state your null hypothesis. So you're gonna compare with the P1 and P2 here. And then the null hypothesis is always equal. Okay, so P1 equal to P2. Okay, how about the alternate hypothesis? Alternate hypothesis, you can have P1 not equal to P2, P1 strictly less than P2, and P1 strictly greater than P2. So same idea, when you have a not equal to, you do have a two tail. Strictly less than, that will be left tail. Strictly greater than, that will be the right tail. Okay, because for the null and alternate hypothesis, we're gonna use the P1 and P2. That's why the first thing you need to do, you're gonna state which one is gonna be your P1, which one is gonna be your P2. So this table is just talking about like this part. Okay, right? And then we do have the test statistic for two population proportions. Okay, the Z will be your test statistic. Use the estimator minus the null value and then divide by the standard error. Okay, and then this guy, that will be equal to 0. Okay, because here, the null hypothesis, they're supposed to equal to each other. Okay, so we're gonna plug it in here. Estimators talking about the sample proportion 1 minus the sample proportion 2. Okay, so that will be our test statistic. And then the standard error, that will be the formula. Okay, so it's pretty complicated. N1 represent the sample size in sample 1. N2 will be the sample size in the sample 2. X1, that will be the number of success in the sample 1. X2 will be the number of success in sample 2. Sometimes they may not give the sample proportion. They may give you the number of success and the total sample size here. Then you're going to calculate by yourself. Okay. So this is the formula. Looks really complicated. So I let you guys use your calculator on the exam or homework. So for the two population proportion, when you guys find the test statistic and the p-value, feel free to use your calculator. And then you need to check the conditions, just like the section 8.2. Large samples, both sample size must be large enough. We use sample proportion P, the pool sample proportion where. This is how you guys find the pool sample proportion, the P hat here. The number of success over the total of the sample size. And then you're gonna check for each populations. When you multiply the pool sample, that will be at least 10. Okay, this is the first population. This is the second populations. And then number 2, random samples. Number 3, independent samples. So samples are independent of each other. Number 4, independent within samples. So for the population 1, every samples has to be independent. Okay, right? This is the 4 conditions. Pretty similar to the section 8.2. And then this is the instruction how to use your calculator to perform the hypothesis testing for the population proportion. You're gonna go to the stat, go to the test, make sure you're gonna find the 2. These 2 talking about 2 population proportion Z-score hypothesis testing. Okay, on the section 8.1, we're gonna be using one population proportion Z-score hypothesis testing. Okay, let's try to do the example together. Researchers from the poll interviewed 2 random samples. Both samples, one taken in January 2014 and one taken in the January 2015, had 3,500 people. In January 2014, 1,575 respondents say they felt pretty good about the amount of money they had to spend. In January 2015, 1,715 respondents felt this way. Can we conclude that economic confidence has improved since 2014? Use a significance level of 0.05. So before we're working on it here, I want you guys to fill in this table. How many number of success X in 2014? What is the sample size for the 2014 and 2015 also? Fill in this part first. So check your work. You should have these numbers, right? Okay, remember I said what's the first step? You guys need to let your P1 and P2. Okay, so I'm gonna let P1 be the proportion in 2014. P2 will be the proportion in 2015. Okay, you don't have to let it like this way. You could put P1 will be the 2015, P2 will be your 2014. It doesn't really matter. Okay, but your answer may be different from mine. If I say less than, you may have a greater than, something like that. Okay, but make sure the first step, write it down. What is your P1? What is your P2? Now we're gonna state the null hypothesis. Null hypothesis is always equal. So it's gonna be P1 equal to P2. And then alternate hypothesis. You're gonna look at here. Can we conclude that economic confidence has improved since 2014? Improved. So it's gonna be better on the 2015, right? So we're gonna be less than. So P2 suppose will be better than P1 here. And this is gonna be left out. Okay? Number 2, we're gonna prepare. We're gonna state the conditions. First one, find out the pool sample. Okay, plug in this number. Tell me what you guys get for the pool sample. You should get 0.47. Okay, right? Now, we're gonna check the conditions. Okay, plug in here to see if you get at least 10. And this is only for the population 1. You do have the population 2 also. Okay, I show you guys the first one. This is good, right? At least 10. Now, okay, now we're gonna show the sample size 1 times the pool sample. Okay, plug in the numbers to see if they get at least 10 here. Okay, good, right? Okay, we're supposed to have another formula for N2 here. But for this example, N1 is going to be equal to N2. Both of them is going to be 3,500. Okay, so it doesn't matter. You don't have to check it one more time. I would say both sample size are the same. So it is enough to show that N1 and N2 are large enough. And also, samples are random, independent, and independent of each other. Okay, check the conditions. Okay, now you're gonna use your calculator to find the test statistic and p-value. Let's do it together. You're gonna follow this instruction here. Okay, go to the stat, go to the test, go down. We do have a 2 population proportion, z-score, hypothesis testing. Okay, then you're gonna look at this information here. So x1, 1,575, n1, 3,500, x2, and n2. And then we have strictly less than, so second one. Go to calculate. Okay. So this is the alternate hypothesis, and we have the test statistic, negative 3.35. And then the p-value. Pay attention at the end here. They do have the E here. This is the scientific notation. Remember, this is talking about 4.00 times 10 to the power of negative 4. So you have the test statistic, and then your p-value will be 0.0004. Okay, so negative 3.35 is somewhere like here. So you could see the p-value will be really, really small. And then we're going to compare with your significance level. Okay, significance level is given. So this is a less than or equal to, so that will be reject. And then we're going to draw the conclusion. There is sufficient evidence to support the economic confidence has improved. Okay, that means like 2015, the population is going to be higher to feel like this way. Okay, so this is two population proportion hypothesis testing. It's pretty similar to one populations. The only things I need to remind you guys that make sure you stay what is your P1, what is your P2. Okay? Okay, try this example. A student is interested in determining if there are gender differences in testing while driving. So collect data from a random sample of 80 men and 60 women. Of the 80 men, 38 report they had tests while driving. Okay, 80 men and 60 women. So this is going to be your sample size. 80 men, 38 report they had tests while driving. 60 women, 27 report they had tests while driving. Assumes the samples were random and independent. Can the student conclude that the proportion of men and women who test while driving are different? Use a significance level of 0.05. Okay, so first fill in this table. And then you're gonna let the P1 and P2. And let the P1 will be the proportion of men who test while driving. P2 will be the proportion of women who test while driving. And then no hypothesis. That will be equal, right? Okay, what is your alternate hypothesis? Strictly less than, strictly greater than, or not equal to? That will be a difference, right? So it's going to be not equal to. That will be to tell. Okay, now we're going to state the conditions. Find out the pool sample first. You should get 0.46. Okay, now we're going to check sample size times the pool sample. Okay, two populations. You have to show it all of them because this time N1 is not equal to N2. Okay. Okay, plug it in. It's going to be at least 10. And then all these values are greater than or equal to 10, so the sample size are large enough. Now, the samples are random, independent, and independent of each other. Okay, it fulfills all the conditions. Now, use your calculator to find the test statistic and the p-value. You should get 0.29. P-value, that will be 0.77. This is really big, right? The p-value here. So, on the picture, and this is a two-tail, so 0.29 is somewhere like here. And then two tails, so one positive, one negative. So the p-value is 0.77. The total area of this part plus this part, that will be equal to 0.77. And this is strictly greater than the significance level. So that would be fail to reject. Okay, fail to reject. So we're gonna say there is not sufficient evidence to support that the proportion of men and women who test while driving are different. Okay, make sure you guys draw the conclusion and show all your work like this on the exam. That's it.